Let's expand our knowledge just a little bit, and we're going to talk about inscribed polygons and also a circle that is circumscribed around a polygon. So an inscribed polygon is one in which all of its vertices are endpoints on the circle. In other words, the vertices lie on the circle, and that would be an inscribed polygon. Now here in this first example, it says find the exact circumference of each circle by using the given polygon, and then it says an inscribed right triangle with legs 7 meters and 3 meters long. So over here on the right, we've got this inscribed right triangle, and I can see that it's a right triangle because I have the little right triangle box there. And I'm told that it's got legs 7 meters and 3 meters long. Now, when I'm dealing with right triangles, I often and most always want to find where the hypotenuse is, and it is always the side opposite the right angle. And so this is the hypotenuse, but look what else it is. It's got an endpoint A, which is on the circle. It passes through the center of the circle O, and it has a second endpoint at C, which is also on the circle. And Shazam, that is also the diameter. And if I know the diameter, I can find the circumference of the circle. Now let's see, we're told it's got legs that are 7 meters long and 3 meters long. Well, I can find what the hypotenuse is, which is also the diameter by Pythagorean theorem. Remember, Pythagorean is a squared plus b squared. It's a sorry looking b. B squared plus c squared. Excuse me, equals c squared. What am I doing? What am I doing? What am I doing? All right. Well, let's see. Let's put that into practice. 7 squared plus 3 squared equals c squared. And 7 squared is 49. And 3 squared is 9. And that's going to equal c squared. And let's see. 49 plus 9 is 58 equals c squared. And if we take the square root of both sides, 58, square root of 58 equals c. And so my diameter is the square root of 58. Now, as always, I want to think about that square root, and is there a perfect square that I can pull out of there? And let's see, well, let's try 4. 4 into 5 goes one time, carry 1, 18, but 4 doesn't go into 18, so that doesn't seem to work. And let's see, what do I'm just curious, if I divide 58 by 2, that would be 2 would go into 5. 2 times carry the 1, 2 would go into 18. 9 times, that's 19. 19, 2 times 19 equals 58, but 19 is a prime number. So the square root of 58 is as far as I can reduce this. Now, before we find the circumference, let me point this out. This statement here, find the exact circumference. Well, the square root of 58, if I can't reduce that anymore, it's going to be an irrational number. In fact, let's see. What is the square root of 58? Square root 58. It's 7.1577, and I don't know how far out it goes. But when it says an exact number, that means that we are not to be rounding any decimals. If it's an irrational number involved, we're not to round any decimals. We're actually to express that answer in terms using that, in this case, square root of 58. So let's go back here. And so now that I've got the hypotenuse, which is also the diameter, I can say that the circumference is equal to, going to be pi the square root of 58 is equal to pi, which is an irrational number, times the square root of 58. And that is the exact circumference. So in other words, if I rounded pi to 3.14 as an example and took this square root of 58 as 7.62 and multiplied those together, I certainly would come up with a number, but it would be an approximate value. It would not be an exact value. And that concept of exact value is important. Now, let's see. Let's go and look at another one. And so over here, we're asked to find the exact circumference of each circle by using the given polygon. And we're told we have a circumcised, in other words, the circle goes around the polygon, and all of its vertices fall on the circle. We got a circumscribed square with the side lengths that are 10 feet long. Well, let's see here. Now, I got a square. I can see that all of its vertices fall on the circle. So it is circle circumscribes the square, or we could say that the square is inscribed into the circle. And one of the things we know about a square is that all of its angles are right triangles. Now, this diagonal has already been drawn through this square, but if I look at this diagonal, well, that forms a hypotenuse because it is a side directly across from the right angle. And we're told that the square, each side, and in a square, all the sides are going to be congruent. Well, they're 10 feet long. Okay, well, how'd he do? All right, let's see. Well, I can find the hypotenuse. Again, a squared plus b squared equals c squared. C is the hypotenuse. So we got 10 squared plus 10 squared. Both legs are 10 feet long. You know what I forgot to do on that other one now that I think about it? I didn't use my unit of measurements in meters. That's terrible. Equals c squared. 10 squared is 100 plus 100. 10 squared again equals c squared. So we got 200 equals c squared, and the square root of 200 equals c. And now I'm ready just to find my circumference, pi times d. But before I do, I want to think about square root of 200. Is there a perfect square I can pull out of there? Well, 100 times 2 is 200. So c could also equal the square root of 100 times the square root of 2. That would be 200. Square root of 200. And the square root of 100 is 10. So that equals 10 square root of 2. Okay. Well, what's my circumference formula? Pi times the diameter. And I might want to write this like this. I'm going to say that the circumference is equal to 10 times pi times the square root of 2. And this is in feet. I'm not going to forget my unit of measurements this time. And that's the exact circumference. Remember, exact circumference, I can't use any of these irrational numbers. Pi is an irrational number. Square root of 2 is an irrational number. And so I just express it as 10 pi square root of 2 because I've been asked to give the exact circumference.